Last time we did the four operations: addition, subtraction, multiplication, and division. When you're dealing with addition, subtraction, multiplication, you have to consider the domain of both and combine them sort of to come up with the domain of the result. When you're dealing with division, you have to do that as well, but you also have to consider anything that causes division by zero. So keep that in mind. You have to include that in your answer if there is potentially division by zero. Or I should say exclude that in your answer. The last regular operation that we're going to do is something called function composition. Composite functions are when you're given two functions, you compose one function of the other function. It's basically a big substitution problem. So a composition of two functions is written like this. Looks like the word, what? Fog and goff. You'll hear people say fog and goff when they're talking about function compositions. Okay? So if you say fog or goff, I'll know what you mean and everybody else in here will know what you mean. But what it really means is you take our function f and you compose it of this function right here. So in our function f, you're going to take g of x and plug it in everywhere you see x in the function f. And you'll see how that works in a minute. So when I see this notation, I automatically switch to this because it reminds me of what it means. I'm taking g of x and plugging it in everywhere I see x in the function f of x. When I see goff, I do the same thing. I switch it into this notation so that I can easily see that what this means is I'm taking the function g, and every time I see x, instead of writing x, I'm going to write the whole entire f of x, and then work my way through the function, and then I need to evaluate it after that. So for example, f of a equals 2a minus 5, g of a equals 4a. I need to find f composed of g at 3, and g composed of f at 3. So let me first rewrite this. F of g of 3. Now I work from the inside out here. This tells me what is g of 3. So I go to g and I find out that g of 3 equals 4, and I'm just substituting 3 in here. 4 times 3, which is 12. So that means g of 3 is 12. So this right here is actually what? 12. So now I just need to find f of 12. So I go to my function f and I plug in 12, and I get 2 times 12 minus 5. 2 times 12 is 24 minus 5. So my answer is 19. So what happened first here? I found this inner thing right there. This inner thing turned into some number, and then I just had f at that number, plug it in, and you got your answer. All right, so I'm given this notation. What's the first thing I should do, probably? Rewrite it. Rewriting it will avoid any confusion. This, to me, is confusing. It always has been, and it still is. So I always rewrite it, and I'm going to write what? G of f of x. And notice how I kind of made a distinction here. F of x is in the middle, so I'm composing g of this whole function. So, and that is at 3. So I'm going to write g of f of 3. Now I just need to find out what f of 3 is. F at 3 equals, here's my function f, 2 times 3 minus 5. 2 times 3 is 6, minus 5 is 1. So now I just have g at 1, which is 4 times 1, which is 4. And that's the answer. All right. We can also compose functions with entire other functions. Really, that's what we were just doing. But now we want to stick an entire function in for x. Make sure you're using parentheses when you do this. And then after you do that substitution, you may have to FOIL or distribute or combine like terms or some other sort of thing. Okay? So, compose functions with other functions. Think of it as a substitution problem. Really, that's all it is. but you're substituting an entire function in. The difference is you're substituting the entire function, wow, it's like I wrote this or something, into the other function everywhere that you see that variable. So if you see that variable 2 or 3 times, you're going to have to make that whole substitution 2 or 3 times and then simplify from there. So for example, we have f of x equals x minus 5, g of x equals x squared. Find f composed of g of x. Now again, f composed of g means f composed of g of x. Now this actually, literally, the way that I've written this here says take g of x and stick it in everywhere you see x. Okay, so we're going to write f of x, which is this guy. But when we see that variable x, we're going to actually write the whole function g of x. So I'm going to write, instead of x, I'm writing what g of x is, x squared. Finish off the function f, so it's x squared minus 5. And then we simplify it. This is an extremely simple problem, probably too simple actually. Maybe I should have picked a harder one. We simplify this thing and we get just x squared minus 5, and we're done. That's it. Yeah, this is a very simple problem. The next version of this, the reverse of that, g composed of f, not as simple. Because it switched around, and you'll see why here in a second. So g composed of f, I'll just go ahead and talk you through this one, means g composed of f of x. And when I look at that, I see that I'm going to take f of x and plug it into g everywhere I see x. So this becomes, I'm writing my g function down. My g function is x squared. But instead of writing x squared, I'm going to write parentheses x minus 5, because that's what f is, squared. Then you got a FOIL. That's why this one's a little bit more complicated, but it's the same idea, okay? So this becomes x squared minus 10x plus 25, and that then is your answer. No, I'm starting with g of x, and I'm writing g of x, but when I hit x, I got to write this instead, okay? All right, yeah, maybe these problems are too easy. Maybe we should have picked a harder problem. But that's the idea that's going on here, okay? This says write the function g, but when you hit x, switch that x into the entire f of x. This says write the function f, but when you hit x, write the entire function g. So that's what we did. We wrote f of x, but this right here turned into g of x, which is x squared. Here we wrote the function g, but when we hit x, this right here turned into the entire function f. You got it now? Okay. Now if there was more going on, like if this g of x was actually x squared plus 2x plus 4, then what you would have for g composed of f of x would be x minus 5 squared plus 2 times x minus 5 plus 4. And then you'd FOIL this out, and you'd have, again, x squared minus 10x plus 25 here, but then you'd also have the plus 2x minus 10 plus 4, and then you combine all your like terms, okay? You see how that works now? Yeah. Okay.